Let's have an example of finding probabilities. So a bag contains 4 red, 6 blue, and 7 green marbles. A marble is drawn at random. Find the probability that the drawn marble is red, the drawn marble is red or blue. Pause the video and try to see if you'll be able to find the probabilities for the two events. Alright, so first we're asked to find the probability that the drawn marble is red. So let's have that. And I'm going to use red ink for that. So the drawn marble is red. I'm going to use capital letter R for that drawn marble is red. Okay. So we know that in our sample space we have 4 red, 6 blue, and 7 green. So the sample space will have 4 red. Let me just write 4 red, 6 blue, and 7 green, which gives us a total of 17 marbles inside our sample space. But don't write it this way. I'm just showing I'm just showing how many elements are there in the sample space because we would need it. And if we're going to draw a red, there are 4 red marbles. So the cardinality, let's write it more properly. Here, the cardinality of that set containing only the red marbles will just be 4. So therefore, the probability, wait, let's not write that therefore symbol just yet. So therefore, we can say that the probability of getting a red marble would be 4 out of 17. If some do not understand 4 over 17 how big or small of that probability is, you can convert it into decimal, which is rounded off to 4 decimal places, 0.2353. In percentage, that's 23.53%. So more or less, there's a 23.53, around 20% chance that when you draw the marble, that marble is red. Now, we are asked, what if it's either red or blue? So based from what we know up here, we have that the cardinality of red is 4 and the cardinality of blue is 6. So the cardinality of red or blue will just be the combination of these two. They don't have anything in common, so we can just add them. So that would mean the cardinality of red union blue, oh wait, I should have used black instead, union blue would be 4 plus 6, which is 10. So therefore, the probability of having drawn a red or a blue marble, there you go, would be 10 over 17, which is the cardinality of our sample space. So 10 over 17 is our probability. That's already in lowest terms. If we want to write this in decimal, that can be 0.5882 rounded off to 4 decimal places. In percentage, this is 58.82%. So there is a bigger chance that you're going to get a red or a blue marble because the chances are it's 10 over 17 or 58.82%. Let's have another example. An experiment consists of forming license plates consisting of 3 letters followed by 3 digits, with repetition allowed. Determine the probability that the license plates will begin with an A, the license plates begins with a vowel and ends with an even number. Pause the video and try to see if you'll be able to find these probabilities. Alright, let us start with this one. The license plates begin with an A. First, our license plates consist of 3 letters. 1, 2, 3. So these are the letters. and 1, 2, 3. These are the digits. So the letters, we will assume it's the English alphabet. So there are 26 letters and there are 10 digits from 0 to 9. We are asked to determine the probability that the license plates begin with an A. The first thing to know is how many license plates can we make all in all. So that would be the cardinality of our sample space. We know via counting techniques that we can have, since repetition is allowed, we can have 26 possible letters here and here as well, while also 10 possible digits for each space. And via the fundamental principle of counting, this will actually give us a whopping number of 17,576,000 possible license plates. So this is the cardinality of our sample space. Quite a lot. That's why we did not even attempted to list the elements of the sample space. Now, how many would be for event A? Which is event A, license plate begins with an A. With an A. So, if we're going to count this, that means this beginning slot should just be A. So that's just 1. And for the letters, since repetition is allowed, there are still 26 possible letters in the second and 26 possible in the third. And of course, for the numbers, there are still 10 possible digits for each of these. So that means the cardinality of set A would be equal to these via the fundamental principle of counting. And this will be equal to 676,000. So that means the probability of having a license plate begin with A is 676,000 all over 17,576,000. In simplest form, this is actually 1 over 26. In decimal form, in 4 decimal places, is 0.0385. In percent, it's 3.85%. So there's a 3.85% chance that the license plate that you will get begins with an A. Let's now go with letter B. Let me just move that up a bit. There you go. For letter B, the license plate begins with a vowel and ends with an even number. So let's have again 4, 5, 6. So if it begins with a vowel, it can be A, E, I, O, and U. So there are 5 possible letters here. That's correct. While here it's an even number. So in the digits, that can be 0. We start supposedly with 0, 2, 4, 6, and 8. So 1, 2, 3, 4, 5. 5 here. While the others are just as is, so with repetition, so this can still be 26, 26, 10, 10. So counting how many possible arrangements are those via the fundamental principle of counting, this is actually 1,690,000 possible license plates. So therefore, the probability that you get a vowel and an even number at both ends will be 1,690,000 all over 17,576,000. In lowest terms, this will be given to us by 5 over 52. In decimal form, 0.0962, rounded off to 4 decimal places. In percent, it's 9.62%. So this one is a little bit higher. There's a higher chance that you're going to get a vowel at the start and an even number at the end compared to when you just get an A, although these are still very low probabilities. Those are examples of finding probabilities.